Hi, Larry here. What we're going to do today is I need to make a plate that covers this enclosure to mount a few switches. So we're going to go through just a quick project on how to make this. First, I don't have any dimensions for this box, so I need to measure it. And it measures 4.033 in length and 2.912, and so we need to record that in our CAD. Now the tricky part is I don't have any drawings or anything on this, so we need to find the distance center to center on these holes. Now this would be easier if I was doing it just right in front of me, but measuring from edge to edge is the same as measuring center to center and more accurate. So that is the measurement I'm going to use on one dimension. And this is going to be how I establish the other dimension. So we're going to use those dimensions when we draw this up in CAD. So the other thing is the switches that we want to mount. And again, I don't have the drawings for any of these switches. So a couple things I need to know is, number one, the hole that I want to put into the panel, and this happens doing it upside down here, so you're just going to have to look at it upside down. It's 0.462. So if we use that dimension to cut in our panel, the hole is probably going to be a little bit too small. I'm going to increase that by about 10 thousandths of an inch to make sure that I don't have to file this hole out at all. Then the other thing we need to measure, I'm just going to measure the width and the height of the things that are on the inside so I can establish where I need to put these on the plate itself. So the other thing, the other switch that I want to mount is this little square switch, and again, this is an Alco switch. I could possibly find the drawing someplace for a cutout, but I haven't gotten that, so I'm just going to measure the part that's going to go through the panel. I've measured 0.473 on the width. I'm going to add about 10 thousandths to that just to make a nice free cutout. Now the tricky part is this has got these little springs that, number one, we can't make the hole any bigger than 0.664. That's the amount that the springs spread out. But obviously we have to make it small enough so the springs will capture this and put it in place. Now the minimum size looks about 610. I'm going to take a shot at about 5/8 of an inch, 0.625. So now we're going to switch over to the screen and go from there. Alrighty, here we have what I've drawn up. I've drawn up all of the outside dimensions on the plate. I've drawn it up as a rectangle, putting in the rounding for the corners, and I just guesstimated what those corners are going to be. We'll see how it winds up in the final. And the mounting holes, what I took is those dimensions, and I have some center marks here, and I just offset those dimensions using the dimension divided by 2 to come up with the locations for these screw holes. I measured the width of the box and put those in. Now you see it's a really wide spaced dashed line. QCAD has a command they call screen-based line types. I don't know that I totally understand it, but it gives you a little bit better presentation when you press that. I believe it scales the dashes to match your screen size. The other thing is I drew in the bezel. Now these are the outside dimensions of our switch, so we know how close we can get it to the edge, and we have the cutout of the square switch up here. So with that in mind, let's just save it. I saved it as stomp switch top DXF. Save it. Now we can do alternate tab over to AvCam. There it is. Now settings. We'll set the layers to and outside. Remember, outside is everything that's going to be on the perimeter. And layer 2, it could be called inside, but it's not named outside. And that's going to cut on the inside. So we'll set that. This just tells us that we've got multiple layers selected. If there's just one layer, it would tell us the name of that layer. On our title bar, we've got all of the layers named. This is from a previous video, so we'll ignore that. And let's look at our settings. We're going to use an 1/8 inch end mill. We're going to be using 1/16 of an inch material. 24 inches a minute is fine. Spindle delay, no changes. Cut depth minus 0.125. Probably wouldn't need to be quite that deep, but that's fine too. Let's just call that okay. Let's simulate it. And also note that we're using the finish cut. Causes 2 passes to go around the inside cuts. Gives better accuracy and better cutting finish. So with that in mind, we're already hooked up to the Panel Pro. Let's just pause here and we'll take a look and see once what we need to do on the Panel Pro side to set things up. Okay, we've got the CAD portion of our work done on this plate, and it's not taking very long at all. And now what we need to do is set this up so we can cut this on the Panel Pro. Notice that I have the origin or work 0 at the lower left hand corner of this plate. We need to match that up on the Panel Pro and tell the Panel Pro where this point is going to be. When we first start up the Panel Pro, it goes through a homing procedure on the 5925 models, or if you use the work 0 setting on your 4824 or 5624, you'll manually set that home position. And your work 0 is the portion where you want to tell it to start measuring from, and that is different from home, and typically is going to be in the lower left hand corner of your work. It's just makes it a convenient place to measure from. It could just as easily be in the middle of this plate, but in this case we've got it right at the lower left hand corner. So now what we've got is the Panel Pro set up and ready to cut. It's been homed already, and remember our measurements from before, and if you don't measure them, you can actually do that on the AvCam itself. So if I just take my mouse, note on the status bar on the bottom there is a mouse position, and so if I put it over here, it says that it's about 4 inches in width and about 3 inches in height. So if I go over and look at my material, notice that I've got this particular one between the bars, and I've got about 5 inches between the bars. That means that I can cut this entire plate without having to have some sacrificial material on top of my bars. As you can see that on my bars, I've cut through them on numerous times, and that was deliberate, and that's a discussion for another day. But anyhow, we have to cut 4 inches by 3 inches, and the lower left hand corner is going to be somewhere right around here. I could just mark that with a Sharpie or something like that. In fact, let's just do that. I just mark that with a Sharpie, and so we can easily go to that point and call it work 0. Now the first thing we're going to want to do is set up our Z0, and so we're going to jog this around. As soon as I turn the axis on. Okay, now we can jog left and right using our numeric keypad, and I'm going to use the 3 key to lower it down, and I'm going to eyeball this. This is not a real precise measurement. Now I'm switching over to the mouse wheel to do fine measurements so I don't crash it into the material, and using just the eyeball to watch for light underneath the end mill, I can estimate where the top of the material is. I can hit Z once to bring up the Z control dialog, and Z a second time to reset work 0, and hit OK. The other things we can watch for is the retract level. Now the area that we've set as our work Z0, this retract level, when we're moving from place to place, will go to this 3/4 of an inch. So 3/4 of an inch will clear the clamps that we have supplied, and if you've got any kind of other obstructions in the way, you'll probably want to set that at a different level. Go slow height. Anytime the Z-axis is below that height, it will move at a slow rate rather than a rapid rate. So let me just exit out of this, and notice we are now at Z0. I'm going to raise that up by 60 thousandths here. Now if I jog, it just moves at a slow rate, which makes it a lot more controllable as we're close to the surface. Now I'm just eyeballing it again by our Sharpie. Now you need to make sure that you've got adequate material all the way around this to support the cut. In terms of the end mill that I'm using a single flute end mill, and that works much better for the 5052 soft aluminum that I'm cutting today. If you're cutting 2024, you may want to use a 2-flute end mill. The single flute end mill works fine on that as well. So at that point, I'm going to hit the R key, which sets both X and Y axis to 0. And now if you look at the status bar, it shows X and Y are 0, and Z is still set at 0.06. Since we have already set the Z0, I can hit the 0 key on the numeric keypad, and it moves it down to the 0 that we've set. You want to take a little bit of caution using that key. No, you have to make sure that you've got that Z set, because if you hit the 0 key and you've got the Z0 set below what your current surface is, you could crash it and possibly damage your material or an end mill. I'm going to hit the 7 key, and now the 7 key brings it up to our retract level. So we've got our work 0 set, we've got Z0 set. Now let's just use another command to see if we have our layout set out properly, and I'm going to use the move to mouse position. And so what this does, you see it turns red, and now I'm going to move to the corner here, and I can observe that we still have bare metal in between. We should not be cutting through the bars. Now the AvCam and the Panel Pro does not have to start at 0, but if you're not at 0, you will get a message telling you that you're not at work 0, just as a reminder. Did you really set your work 0 to match your file? So let's just leave it up here in the upper right hand corner at the moment, and we'll see once what happens. Right now I'm going to put on my headphones and and we're going to put the splash guard in place. We're going to check to see if we have enough coolant that covers the coolant pump, and we'll go ahead and cut this. Okay, we've got our splash guard in place, and so all we have to do now is either open up the cut dialog and hit cut file. Now I've reloaded this file since a bit ago, so it's showing red, and red would mean that it needs to be simulated first. So let's hit simulate, and our estimated cut time says it should take us about 1.1 minutes to cut this out. So let's go ahead and cut this. There's a couple different ways we can go about this. We can either hit the cut dialog and click cut to file, or we can use the keyboard shortcut, and those are found in the help file. Hit C, and it brings up the cut dialog, and with the cut dialog open we can hit C again, and now this is our message that says we're not starting at 00. We know that we've set 00, so we're going to tell it it's okay. We've cut the file now, it's dropped out, and notice that the actual cut time is actually 1.1 minute. For normal cutting, that estimated time is usually pretty accurate. For things like lasering or engraving, the cut time is not terribly accurate. We need to do some more work on that. Alright, so in 1.1 minutes, we have gone ahead and cut this file that we've cut out. A couple things to notice. Number one, when you cut it off, it is always going to have this cutoff nib. You're going to have to take care of that with a deburring wheel or a file, something like that. The other thing to notice, we used the rough cut and finish cut on these inside cutouts. I don't know if you can see it on the video, but the cut quality is way better on this inside cut than the outside. On the outside, you can see it's just looks a little bit rough. That's what a single cut looks like. So let's see how our fit works out. So we've got fits like a glove, just perfectly. So the other one is this square switch, and we just measured that out, and width-wise it's just perfectly. It's just a little bit on the tight side for these springs, and we could have benefited from possibly a manufacturer's cutout drawing on this. The other thing is that we used a 1/8 inch end mill, so the corner radius is going to be no less than what your end mill is. So you could consider using either a smaller end mill, or if you need to get in there in the corners and square that out, you could use a little bit of a file or something like that and square out those corners. The other thing is, how does it fit on the enclosure itself? Well, outside dimensions looks like just pretty much perfect. So the other thing is how about our mounting holes? And this is a little bit subject to the quality of your measurements, obviously. These are not the screws I'm going to use, but just to show that it fits just perfectly. So this is not a full-blown project like you'd make a panel on an aircraft, but it's the same process, same procedure, and the same quality of results. Thank you for watching.